I am considering the possibility of running a contest to see if I can motivate anybody to build a circuit that might work. I don't know. All I've done is simulate it, so I really don't know if it would work or not, or how to build it. I mean, I have some ideas. It's a little peculiar because it's Overunity. It's not conventional. And its power gain is ridiculously large. And what started me on this quest over 6 years ago was a personal matter, a failure that resulted in the failure of my RAV4 EV from Toyota, manufactured or sold, I should say, or leased or sold in 2002. So it's a 21-year-old car, and its nickel metal hydride battery pack was replaced by a condition pack by Battery MD up near Sacramento, California. Its windshield has been replaced. Its auxiliary battery under the hood has been replaced. But the battery pack has died and has lost its ability to store a charge for more than, 5 seconds or 30 seconds. So using the knowledge of Alan Coccioni, I thought I would adapt his approach to modifying this car to run power through the battery pack from an auxiliary source to supply at least cruising power, like 50 mile per hour cruising speed on a freeway. Once you're up to cruising speed, just all you have to do is maintain it, and it takes about 50 amps to do that. Let's see what else. So Alan is the silent partner behind Elon Musk's Tesla Roadster and other model cars. That's why his car, the Tesla, has such good acceleration and range, because it was predicated on Alan Coccioni's hobby of developing electric race cars and racing them. He started a company called AC Propulsion, and he designed the motor controller for the EV1 that was leased, not sold, by General Motors between the years of 1998 and, 2003-ish. Toyota wanted to get in on the bandwagon along with a few other companies, Ford, I believe. They created an EV Ranger, I think, an EV pickup, and Toyota created a modification of their RAV4 EV without actually modifying the car. So it was still a very heavy car. They increased the suspension to accommodate an 1,100-pound battery pack of 2 dozen 100 amp hour 12-volt nickel metal hydride batteries underneath. And they switched which side the steering wheel goes on, and they forgot to switch which side the door opens on the back side. But other than that, and they put the spare tire underneath that is normally on the back side, on the door, on the back door, the very, very tail end back door of the car. Other than that, they didn't make any other changes, so it's still their gasoline version, but with a twin AC motor under the front hood, and of course a motor controller that was designed by Toyota, not by Alan. But Alan created the first hybrid for Toyota back in 1996 for the RAV4 EV, and he did it with a little trailer hitch, a mini trailer, hitched to the back end of the car. It even had the hydraulics necessary for going in reverse. It used a gasoline motorcycle engine to run a little generator, and it proved to be more efficient mileage than a gasoline car. So thus the hybrid idea was born and proven to be very effective. Now, it supplied the necessary voltage for the twin AC motors of the electric RAV4 EV of that era, but it only supplied up to a maximum of 60 amperes for cruising speed. So you would use, the battery pack would kick in when you accelerate, and then when you're cruising, the gasoline, motorcycle gasoline engine would kick in to supply up to, I think, 21 kilowatts to cruise. So the voltage, I believe, was somewhere in the vicinity of 345, a low of 345 to a high of 360 volts is what the twin motors require. But the amperage for acceleration is somewhere around 206, 210, and of course cruising is somewhere in the vicinity of 50 amperes. So what I'm thinking is that this circuit I developed 4 years ago has so many different variations possible to it, and it's a very intriguing circuit because it's predicated on 5 coils in 3 sets. 2 of them are large coils, which I am guessing might be iron coils, insulated iron wire coils, and they, in the present incarnation of the circuit, each of those 2 coils are 1 Henry of inductance each. And then there are 2 small coils that I'm guessing might be copper, insulated magnetic, standard winding wire made of copper. And those are quite small, in the vicinity of 2 microhenries of inductance each. And then the 5th coil may be an insulated aluminum wire coil, which is also in the vicinity of 2 microhenries. And there is a standard transformer also included that helps as a kind of ballast to help stabilize the pulses, because the circuit basically generates reactive power in the format of the current and the voltage are triangle waves, and they are out of sync, out of phase with each other by a separation of 1/2 cycle, exactly 180 degrees. And under those conditions of reactive power, it wants to surge because it's lossless, it's useless, it cannot be spent. And it surges to infinite oblivion if not for the fact that it has been tuned with the help of that transformer, the addition of a transformer. I believe it's a step-down transformer, so it goes from 2 microhenries to 200 nanohenries, and then it has a capacitor shorting out the 2 sides, the primary with the secondary. So instead of it surging to infinite oblivion, destroying the entire circuit, it collapses in a periodic manner. And the RMS of, averaging out of those collapses and surges comes out to a very interesting figure in the ballpark of what needs to be supplied to my RAV4. And another portion of the circuit has a full diode bridge, and it's that portion that I think would be the best area to feed through to replace what Alan Caccioni was supplying by his generator, passing it through the battery pack to go to the motor controller of the RAV4 EV, because it's this portion of my circuit is DC, although it has shown the possibility of collapsing periodically and not sustaining itself, but under the current version that I'm supplying for this contest, it seems to be stable, and so the amperage is stable at around 312 amperes, and the voltage is stable at around, I forget, it's somewhere, was it 400 volts? 450. Somewhere around, I think it was 450 volts. I'm not sure. I can't remember. My memory's a little dim. And the wattage was 117.2 kilowatts, I believe. So it's more than adequate wattage, amps, and volts. The wattage for full throttle acceleration on my car is somewhere in the vicinity of just under 70,000 watts. So 120,000 watts more is more than enough. And so that's what I wanted. I wanted more power rather than the exact amount or less, because we can always throw away excess power. That's not a problem. The problem is having adequate power for the immediate demand of acceleration, because the batteries are dead. And it might be possible, I'm conjecturing, that they might come to life over time. They might get a kind of reconditioning and come to life and be able to store a charge should this energy be passed through them in a normal discharge manner. They're all connected in the RAV4 EV. They're all connected in series to get the adequate voltage from each of those 12-volt batteries. I believe that's a total of 288 when fully charged, and the motor controller steps it up in order to satisfy the requirements of the twin AC motors. But I just assumed that I had to go on Alan Coccione's information. So rather than supply the amount of voltage that the fully charged batteries would have supplied, I overvoltage the supply slightly according to what the motor controller requires, because the batteries are not going to be there to help. And that's the way Alan did it, so I'm assuming it's okay, provided I stay within those limits. Anyway, so I'm supplying a little excess to what those limits are. Certainly a lot more than the cruising amperage. So that's kind of the rundown. So it motivated me over 6 years ago to, when my car died on me and I couldn't get adequate help to prevent it from becoming destroyed, its battery pack. Once I did manage to get it to a Toyota dealer for an inspection, and they were familiar with that model car, so they had the equipment and the knowledge and the expertise. They did everything they could, but based on conventional standards. They couldn't do anything per my request, anything that I'm now seeking a solution to. Of course, I didn't have any knowledge back then either, and neither did they. Well, I had a little knowledge, but not really a lot. But now I've got 3 different articles, 2 of them already published and 1 about to be published in peer-reviewed journals. So I already know that the physics behind it supports free energy and overunity, and that it's a misconception or disinformation to think otherwise. Physics is behind it as well. Certainly not conservation of energy the way we interpret it. But general relativity certainly does back up overunity and support free energy, and a proper interpretation of conservation of energy in a limited context, and not the sweeping context that is conventional, but more restricted, is possible to comply with the general relativity support of overunity and free energy. In other words, more energy out than what goes in. So we're not creating energy from nothing. We're just expanding. Energy is like a rubber band. It's not really a solid piece of wood that you would burn in your fireplace and consume. It's more like a rubber band in that you can expand it or contract it based on the modifications that reactive power can engender upon real power. Once real power gets converted into reactive power, we can modify it as reactive power to expand it or contract it over time, and seemingly make it disappear and seemingly make it appear once that expanded or shrunken reactive power gets converted back into real power. And there are complicated ways of doing that conversion from reactive to real. The simplest is simply to use a resistive load, and that's why I use a full bridge diode, which does not convert the voltage. The voltage still alternates as triangle waves, but the current does move forward in a direct manner, in a non-alternating manner for the most part. For the most part. These are all relativistic statements, and that's really all we're dealing with when we're dealing with electricity, because the electrons are doing their own dance, and it's not random. It is intelligent, creative expression. Electrons are intelligent beings, but we're creating and averaging a statistical situation, and that's all electrical engineering does anyway. It's not an exact science. It's more an art form when it comes to the application of the science, because the science is just theory, which is all very nice and good, but it's just theory. And once it's applied, it becomes more an art form than anything else, and the result is a statistical result in which you want to get the results you want most of the time and mostly accurate on the mark and not too much off the mark. So it's really, we're gambling when like anything else, but we hope to be as accurate as can be so that the twin motors can be satisfied. In fact, it's possible you don't even have to supply an AC motor with a sine wave. As I learned a few years ago, you can supply it with square waves that are engineered in such a way as to mimic a sine wave closely enough that the AC motor is fooled into accepting it and not misbehaving. So everything can be done that we want to do. It's just a question of having the technology to do it and the gall, really, the courage, because Overunity is predicated on the belief that if you feed a circuit all the energy you think it needs plus a little extra to cover its losses, you will suppress Overunity. It will not happen. And that guarantees a self-fulfilling proposition, a circular logic to the conservation of energy. This is the problem with the conservation of energy, and it's really a question of how we misinterpret it, by how we apply it. But if we presume that it's possible to get more energy from less through the agency of negative impedance, which is supported by Foster's reactance theorem, then we are left with the presumption, to not feed the circuit the full amount of energy that it is required to run on. Instead, to not feed it anything and put it in a position to be receptive, to listen to its environment, because the amount of energy in our environment is adequate for all of our needs. We don't have to supply any energy at all. Just get the circuit to listen to its environment and make use of the energy that's in the environment and maximize it to the extent that is whatever is required to satisfy its requirements for energy. And then the reactive power of Overunity kicks in, but only if we allow it to and not suppress it. So I think I've said everything that needs to be said. If you want to see my second peer-reviewed journal article, the first one I was still groping, so I like to ignore it. But the second one is pretty much on the mark. I'll include a link at the bottom of this podcast, as well as a link to the contest, the instructions for how to build. So I live on Social Security, and I don't have a whole lot of money to give away as a reward for this contest. Mostly, all I can surmise is that pat on the back, thumbs up, way to go, because I'd love to be able to run my car, take it out and drive it for a change instead of it being 3,000-pound paperweight at this point. That's all it's good for. I'd like to take it to the car wash and give it a wash. The inside has been clean because I never opened it, but the outside could use a wash. It's a little dusty. And unless we can get investors, because I don't know how to look for investors, or grants, because this is quite a challenge to get investors involved with something like this, because this is so out of the box, so egregious, so out of the herd style of thinking, out of collective consciousness. But if we could get investors, then surely we could get some prize money that would motivate people to get involved. And then, of course, students, places like MIT might get involved because then it would help pay for their expensive tuition. But at the moment, all I can do is say, I have nothing to offer except a challenge. I challenged myself to understand this subject and design working simulation models. But that's the best I can do. I'm 65 years old, and I wish I was younger. I wish I had pursued this 40 years ago when I first learned about it. But I thought, inventors seem to have it under the belt. I don't think I need to help them, by getting involved. And I was wrong, because the person I was studying at the time, Lee Rogers, we don't see a commercial product of his invention, running a car on compressed air, and it compresses air as it drives along. Although he did test it on the flatlands of Florida, not up in the Alps or going up a steep incline, but still, nonetheless, it did manage, and if he drove faster than 20 miles per hour, it would not stall, and it did manage to compress air as he drove. But who knows of this, we don't see it, right? It's not for lack of his trying and engineering it. It's really our collective consciousness doesn't support this. Only the consciousness of single individuals who have risen to the occasion, it supports their consciousness, or mine. But getting it to materialize in a commercial manner is, we can keep trying. So this is my attempt to try for my own direction. Not expecting it to reach the patent office, because I know what the patent office is like. They're totally against conventional wisdom, they're totally against something like this. They're quagmired in the conventional wisdom, which is not scientific. It's really a slant, an agenda to keep things just the way they are, basically. Keep the status quo intact. And then you can read into that anything you like, the particulars. But generally, in a very broad sense, that's basically the agenda. So I can't expect much to come out of this. I'm a hobbyist, basically, a theoretical hobbyist at that. The only circuits I ever built were bionic circuits, so I have no expertise in power circuits or power supply circuits. And I'm quite frankly afraid of getting electrocuted because there is that risk. The circuit is based on a design that is a kind of like a resonance, but is not the principle of resonance. It's a different type of resonance because it's a periodic collapse, so it's not your RLC style resonance. It's something else, and I still don't understand it, so I can't make it happen. I basically bump into it on occasion, and I have on a couple of occasions, not too many, less than half a dozen, basically. Because reactive power is not stable. It cannot be stable by definition. It either diminishes over time or it increases over time because it's lossless. It cannot, and because it's lossless, it cannot be sustained. So all you can hope for is that to get it to surge and then periodically collapse. And then it doesn't collapse all the way to zero before it starts picking up again, and then collapse again, and then surge, and then collapse, and surge and collapse. And if the pulsations of surges are close enough together, maybe it's possible without further modification to fool an AC motor into thinking that that's an adequate power supply. Or maybe it has to go through a pulse width modulation set of circuits, or a block of circuits to modify it further.